Good morning, one and all. In a previous lecture, we will discussing about the Maxwell equations for a static field and a time varying field. Okay, what are the equation of that? And in today's lecture, we will discussing about the Maxwell equation for harmonically varying field. If their field is harmonically varying field, then what is the Maxwell equation of that? Let we have to know that in that equation harmonically varying field, these are the two equations, means that there is a point form and a second is a integral form. Okay, for let we will discussing about the point form equation in a harmonically varying field. A point form, the equation is that first del cross e bar, we are the del operator, and taking cross, then we will get minus jw d bar. Okay, and we will putting the value of d bar, then we will get a jw mu h bar. Second equation is that the del cross h bar means the j bar plus jw d bar, then we will get a sigma e bar plus jw into the bracket epsilon e bar, then we will get the sigma plus jw epsilon into the e bar. Okay, then third equation we will get that the del dot t bar, the value of that the del dot d bar then is equal to the rho v. These are the harmonical varying field in a point form equation. Then del dot b bar is equal to the 0. Okay, and this is equation which can be the in a point form. Okay, in point form, what are the equations in a point form? In point form, the closed integral of e bar dl is equal to the that minus surface integral of jw into the b bar into the ds. Okay, then we will get the surface integral of jw into the mu into the h bar ds. Okay, then we will get the closed integral of e bar dl is equal to the j omega mu into the surface integral of h bar ds. These are the equation we will get in a integral form. Another equation is the integral form, which is based on different parameters, is that the closed integral of h bar dl is equal to the I plus surface integral of jw d bar dot ds. Then we will get the surface integral of j bar ds plus surface integral of jw epsilon e bar into the ds bar. Okay, then we will simplify that equation. Okay, then we will get the value of the value of putting j bar, the value of j bar is the sigma e bar into the ds, we putting value of that, then we will get the equation of that the closed integral of h bar dl is equal to the sigma plus jw epsilon in bracket surface integral of e bar ds. Okay, and the closed integral of h bar dl is equal to the sigma plus jw epsilon. Okay, in the surface integral of e bar ds. Okay, then we will get last two equations in that harmonical varying field, is that the closed integral of closed surface integral of d bar ds is equal to the closed volume integral of rho v into the dv. These are the equations. Then we will get the closed integral of a b bar ds is equal to the 0. These equations these equations we will get in that harmonically varying field. Okay, these are equation we are the very important in the exam point of view, and you must be remember that the was what is the equations. Okay, these are the harmonical varying equation. Okay, and summary is that this is a summary of Maxwell equations. This table is the most important. You we know that what is the equation and significance, and based on that, first is the Faraday's law, second is Ampere circuit law. This equation is a Roe Gauss's law. Okay, then last equation is a no isolated magnetic charges. Okay, this table must be know that about first Faraday's law, del cross H bar, which can be the Faraday's law, and this equation in the integral form we will take in the closed integral. Then Ampere circuit law, del cross H bar. Okay, this equation in Ampere circuit law, this is a Gauss law. Okay, and these are non-isolated magnetic charges. Okay, these are the four equation. There are a totally summary equation, and it is the most important due to the exam point of view, and all of student must be the remember that this is a differential or a point form. This is a second is a which are also the called as a point form, also the or a differential form, integral form, and significant. These are the four equation, and in that equation this is the last chapter, which is a Maxwell equation based on that. And this is equation called as a Maxwell equations. And then we will discussing about that the Maxwell equation for a static field. If field is static, then what is the value of that this point. Okay, field is statics. Okay, then field is a varying field. The what is the value of that the value of that Maxwell equation. A field is a good conductor, then what is the value of that equations. Okay, if field is a harmonical varying field, then what is the value of that. Okay, and you must remember about that this value. Okay, and this is a called as a Maxwell equations for the harmonically varying field.